to self, do the deal with the microphone and the shirt before the chalkboard. I have all this chalk dust all over me. Okay, so a couple announcements before we get into the, I'm going to talk about the circle class today, staticness, publicness, privateness, all that stuff. So there is a midterm next week. It's on Wednesday. There will also be a lab quiz on Thursday. So obviously there's no homework due next week because I'm not really that cool and insane. But there will, of course, be a homework due the following week. I'll spend some time talking about that 1 week from today. That's going to be the first of the course project components. There will be 3 or 4 homeworks and 3 or 4 labs that will all sort of deal with creating the course project, which is going to be the Oregon Trail game. So as many of you noticed, even though we're the computer science department, we seem to have some problems keeping like a computer system up and running. And the web server decided to die yesterday right in the middle of lab section, actually the beginning of lab section 7. These things happen from time to time. It's actually really embarrassing for us instructors because we're not the ones who actually run the web server, but of course when the web server dies, everything just goes haywire. If this happens in the future, so this actually one semester this happened, it was off for like half of the Thursday of the lab quiz, and that was really a nightmare. If this happens in the future, and sometimes these things unfortunately will happen, they shouldn't, but they do. If it's 10 o'clock at night on a Thursday night and the web server is down, and it's been down for an hour, obviously we're going to give you an extension on turning in your homeworks because that's really the fair thing to do. Feel free to send me emails, but usually when the web server goes down, the entire CS system decides to go down with it, which means my email is down as well. So I wasn't able to get email during that hour and a half. But if that does happen, we'll obviously give you a chance to submit whatever assignment that you're dealing with the next day as well. I believe that we're now going to be basically copying everything over a couple places so that hopefully if this happens again during lab, it won't sort of spell the end for lab or the quiz or whatnot. And as you saw in the email I sent out, I extended the homework deadline by, I think, 2 hours. And everybody in lab section 7 is getting a 24-hour extension. And if that does still create problems for you, just let me know, and we can talk about that offline. So obviously, assignments is no homework due this week, but there is one due next week. And everything else is pretty much the way it's been for the last 10 slides. Questions, comments, concerns? Yes?
About domestic clickers,
Mm-hmm.
do you have a list of, the working clickers online?
I don't. I've been promising for quite some time that I will, and I will really, really soon now. This weekend I should be able to extract that list. Other questions, comments, concerns? Okay. So we're going to talk about creating classes. The first example we went over is, the car class. For use in maybe a computer simulation, a car game, what have you. The next example we're going to go over is the circle class. And in this example, I'm going to finally explain why we care about private, why we want things to be private, and I'm going to start talking about static versus non-static and other such issues. If you have any questions, please feel free to ask, because everything sort of builds upon everything else. So we're going to talk about the design of a circle class. Of course, the first question is why? Well, there are many programs that use circles. Photoshop, there are lots of circles there. You can have the ellipsoid tool, I think it's called. PowerPoint, Word, many programs allow you to create circles and in some sort of graphical drawing program. So maybe that's what we're using the circle class for. And the circle class is going to have sort of the standard properties that we would expect of a circle. Maybe it has a color, maybe it has a radius, maybe it has some sort of XY position. But the real reason I'm going over the circle class, of course, is so I can give you another example of how to create a class. In particular, a lot of the topics that I've talked about so far, constructors in particular, I'm going to use this to sort of reinforce the existing material that we've talked about, such as constructors, and use it to sort of introduce new materials, such as staticness. Right. We're going to talk about why we like accessors and mutators and why we think they're the greatest things since sliced bread. Talk about visibilities, static keyword, all that fun stuff in this one example. So anytime we're creating a class, we first have to think about what properties should that class have? What attributes? What instance variables should it have? Well, obviously every circle has a radius. Sure, it has a diameter, which is twice the radius. We'll just pretend, we'll just only look at the radius for this one. And pi, that's certainly a property of a circle. That's the ratio of the circumference of the circle to the diameter. And that's pi to some large number of digits. Now, you could obviously have a lot of other properties in your circle class, right? You could have a color, you could have a line thickness, you could have a fill pattern, you could have an x and y position, maybe you have a height if you want to pretend it's a cylinder, et cetera, et cetera. We are going to ignore all of those and say, for the sake of this particular example, we only have two properties, a radius and pi. Right, color, x, y location, et cetera, et cetera. As I said, we're only going to care about the radius and the pi. Okay, so this is how we want to create a new circle. Circle C equals new circle. The standard object creation lines that we've seen throughout the course. And if we were to actually define our circle class, it might look like this. Public class circle. We give it a radius, which is a double, so it can hold any sort of floating point value. And we give it pi, which is 3.14159, et cetera, et cetera. Realistically, pi should probably be final, meaning you can't change it because the value of pi is not likely to change. I'm going to develop this for a little bit before I actually make pi final. Notice here that nothing is static. Again, we're going to be talking about static. We should get to a fair amount of it today. But notice now that nothing is static. We also are ignoring privateness of the fields. Yes, all fields should be private. I'm going to explain. They're not private yet, and they will be soon. We don't initialize radius. I don't actually give it a value. Keep in mind that Java, when it sees a variable that's part of a class, right, both of these are part of the class circle, Java will give it an initial value. Numbers go to 0, booleans go to false, references go to null. If it sees a variable that's inside a method, Java doesn't give an initial value because Java's kind of stupid that way. So even though we don't give radius a value, Java is going to give it the value of 0. We're ignoring the fact that it's public, private, any of that stuff. And this is what our circle looks like after we've created it. Keep in mind that this particular line, circle C equals new circle, does four things. Creates a reference, creates the object, makes the reference point to the object, and then it's going to call the constructor with no parameters. It's going to call the constructor that has no parameters, which you noticed we actually haven't specified yet. We'll get to that in a minute or two. So anytime we want to access some part of the circle object, whether it's a property, or meaning an instance variable, or whether or not it is a method, we just access it using the period. The period, of course, means follow the reference. So if this is our circle C equals new circle, and I say, I say something like C dot pi, that's going to start at the reference C, period means follow the reference, and print out the value in the pi field. Or C.radius will print out the value in the radius field. We've seen this before, system.in. So we can do system.out.println C.radius. So here we're saying from the system class, I'm going to eventually call the println method. I'm going to print out C.radius. Start at C, follow the reference, print out the radius. That's just going to print out 0. I could also say C.pi equals 4. This, of course, is going to be a bit of a problem because if we're using pi to start figuring out things like, the area of the circle, and it's set to 4, we're not going to get quite the right results. If pi was final, this would not be the case, right? Because you can't change the value of a final variable. Pi will eventually be final, but not yet. But it still does the same thing. From whatever C points to, it's going to try to set the value of pi to 4. So let's say I now have a second class. This class is in a circletest.java file, so I have two files going at the same time. Just like you had a complex and a complex usage in the last lab, here I have a circle class and a circle test class. Notice here what I'm doing is I'm declaring a variable, but not initializing it. It does not have a value. I then create a circle C equals new circle, and I print out x. Notice that we have not initialized the value x. We just said int x. Because x is declared inside a method, right, it's declared inside the main method, Java is going to complain, and it's going to print out variable uninitialized error. Yes? Here? We haven't defined any methods there yet. So Java is going to complain about this because x has not been initialized. Java did not initialize it for us, and we did not explicitly initialize it. So Java doesn't like it. It starts whining, and it won't actually compile the code for us. Again, when a variable is declared inside a method, such as this x, Java will not initialize it by default. Now I'm going to change this, and just the blue line is what is changed. Is that blue line visible to the back row? Yes, OK. We've had some contrast issues in here in the past. So now, instead, I am changing, instead of printing out x, I'm printing out c.radius. Notice again that we have not explicitly initialized radius. We did not tell Java what to set it to. But Java is not going to complain this time. Because radius is a field of an object or field of a class, Java does decide to initialize it that. Quite frankly, Java should initialize things all the time. I think it's kind of stupid they don't, but that's what we have to work with. So this will be allowed because Java, because radius is a field of a class or a field of an object, Java will initialize it to a default value. Numbers go to 0. So here, Java's happy. It prints it out. It compiles it. It runs it. And everybody's happy. Right. So somewhere, sometime, a variable must be initialized before it's used. You need to set the value of the variable before you can print it out, you can read it, et cetera, et cetera. A local variable is something inside a method, meaning it's local to that method. Whereas an instance variable or a class variable, we have not yet seen the difference. That's something that's declared inside a class, but outside a method. And that's what Java will automatically initialize. Numbers go to 0, booleans go to false, references go to null. It's counterintuitive. OK, so we now have our properties of a circle. Again, we only care about radius and pi. We could easily have added color, line thickness, x, y position, fill pattern, whatever you want. So we need to figure out a number of what behaviors we want our circle class to be able to perform. And there's a number of things that we can, that we're going to want to do. We're going to want to start creating a bunch of circles. So we can start populating our graphics program with lots of little circles. We want to be able to change them. Once the circle's created, we'd like to be able to make it bigger or smaller. Find out, given some circle, if you pass a circle in as a parameter to a method, we'd like to be able to find out how big that circle is. Compute the area of a circle, pi r squared. Plot it on the screen. We saw that in the car class. We were able to plot the car on the screen. And a couple others that we're going to see here and there. But these are a reasonable first take at the various methods or behaviors that we want our circle class to do. Right, so we're going to do these all as methods. So this is how we create a circle. We saw this before. Circle C1 equals new circle. And remember, this does 4 things. Creates a circle reference. The C1 reference. Creates the circle object. Makes the C1 reference point to the circle object. And then calls the constructor with no parameters. We know it's that constructor because there's nothing in between the parentheses there. In particular, keep in mind that a constructor is a very special method whose sole purpose is to allow you to create or construct an object. It's only called when you are first creating an object. You can't call a constructor later on. When you first create an object, that's when the constructor is called, and that's really its sole purpose in life, is to start or give birth to that object, if you will. So here we have a slightly different version of the previous one. Circle C1 equals new circle 2.0. There we are giving a parameter to the constructor, a double parameter. And in particular, we want that to be radius. And it does the same four things, but this time it's calling the constructor that takes in a single, it's probably a bad choice of words, takes in one double parameter. And what it's going to do is it's going to set the radius of that, oops, maybe not. Eventually it's going to set the radius of that circle to 2.0. That's the point of the constructor that takes in a one double parameter, is it uses that value in that parameter to set the radius of our circle object. Question?
I had a question on the last slide.
Oh, there we go.
Like when it's doing the four things, when it initially creates that circle object, then the radius is 0.0, right? And then when it calls a constructor, does it call it again, or is the first time it's calling it, and then it converts it to 2.0, or we don't have to worry about it?
The question is, when it first creates a circle object, it's 0.0. So when the way Java works is it first will create the circle object and set everything to default values, or the values you specify when you say double radius. And then it calls the constructor once and once only, and that constructor will reset it to 2.0. The thing that we all need to keep in mind, and this is anybody who's using Java, is when these four things all happen at once. And when they are finished happening, then the radius is 2.0.
Why does 2.0 refer to the radius?
The question is, why does 2.0 refer to the radius as opposed to, for example, pi? It's a good question. I'm going to show you in 2 slides. Okay, other questions or concerns about this one? Okay. So, again, the purpose of the constructors is solely to initialize the objects once they're created. Pi's already set, and likely pi's not going to change throughout the running of your program, so really only the radius needs changing. So this is one constructor, so a constructor that takes in no parameters. And notice what's happening here is it's setting the radius equal to 1, a unit circle, radius 1. This constructor is taking in whatever parameter is and setting the radius equal to it. So the question that was asked is, why is the radius being changed in the particular parameter? And it's because that's what we wrote when we wrote the method. We could certainly rewrite this method and say pi equals r, and then if you call a constructor and you give it one double parameter, it changes the value of pi, but that's probably not what we want to do here. So this is how we define our constructor, that when it takes in one double parameter, it will set the radius equal to whatever that parameter is. And another thing to note is we have two methods of the same name. Now, both of these are constructors, and Java treats constructors slightly differently. In particular, a constructor must have the same name as the class. This is a public class circle. The constructors are both called circle. And constructors don't have return types. Java knows it's a constructor because it has the same name as the class. So Java, you don't have to specify a return type. And in fact, you can't specify a return type. But you'll notice that there's two methods of the same name. This is called overloading. We've seen this with the substring method in the string class, or the value of method in the string class. Depending on the parameter list provided, Java can call a series of different methods all with the same name, but Java differentiates them based on their parameter list. I'm going to talk a bit more about overloading later on. Right. The name of the constructor is the exact same name with the exact same capitalization as the class, and there's no return type. So I've created my new circle. This calls the constructor with no parameters, which if we go to the previous slide, is going to set the radius equal to 1. And that's what actually happens in memory, right? It does those four things in that order. So a double takes up 8 bytes of memory. That's just how a double is defined in Java. It actually takes up 64 bits or 8 bytes of memory inside a computer. So a circle actually contains 2 doubles, right? It has a double radius and a double pi. So every circle object that you create is now taking up 16 bytes of memory. The methods defined in an object don't actually take up space for reasons that you'll see in much later classes. So any circle object we create takes up 8 bytes of memory. 5 circle objects are, 16 bytes of memory. 5 circle objects are going to take up 5 times 16 or 80 bytes of memory. Did I do that right? I think so. We're going to see this when we start talking about static in a couple slides. We're going to see this in a bit. So this is a bit big for me to display on my slides. So I'm actually going to shrink that to this representation. I'm basically getting rid of the bottom half of that. It's just a shorthand representation so I can stick lots of them on my slides. This is our circle class so far. We have our 2 constructors and our 2 fields. Okay, how are we doing with constructors? Okay. So at this point, I think that's fine. There's a couple people who are a bit confused, which is the lower 2. Again, this is something that I'm going to be presenting a series of classes over the next number of lectures, and each time I'm going to go back and spend some time reviewing it. This, I believe, is better than it was last time. So we're getting there. Okay. Again, every year they come out with demotivators, and they've kind of given up just because there was 1 year or 2 where the demotivators were really kind of dippy. We've seen some of those in this class. So these are some of the ones that came out about 2 years ago. Madness. Madness does not always howl. Sometimes it is the quiet voice of the sometimes it is the quiet voice at the end of the day saying, "Hey, is there room in your head for one more?" Now, if I didn't flub it, it might actually be more humorous. Sacrifice. All we ask here is that you give us your heart. This is one of the ones in my office because one of the previous classes loved it. Compromise. Let's agree to respect each other's views no matter how wrong yours may be. Do it later. The early worm is for the birds. Or you've heard the saying, the early bird gets the worm, but the second mouse gets the cheese. Okay. So this is the circle class. This is what we've seen so far. 2 fields, 2 constructors. Consider this code. We create 4 circles, C1 through C4. In memory, we're creating 4 circle objects in memory. And the objects themselves, and I'm not counting the references yet, the objects themselves are taking up a total of 4 times 16, right? So each circle takes up 16 bytes. 8 for the radius, 8 for pi. So 4 times 16 equals 64 bytes of memory. That's what memory looks like. Not counting the references, which I'm just going to kind of ignore for this analysis. Each of these is 16 bytes for a total of 64 bytes. What if I did this? Circle C1 equals new circle all the way up to C1 million equals new circle. Now, obviously that would be a pretty long program because you'd have 1 million lines. You could easily do a for loop and shove them all into a vector. for I equals 0, I is less than 1 million, I plus plus, and just do your vector.add new circle. So you certainly could write a program that would do or compute or create 1 million circles. This might not be the best way. Yes?
But then how would you put I into the name of the circle? Because it would be I all the time. So you just overlapping all the name circles if you did it in formula.
So I'm going to use pseudocode. I equals 0 to 10 to the 6 because I ran out of space. V.add new circle. Just do something like that. And that just, so what's actually, imagine that you could actually read this. Let me try writing this again. V.add V.add new circle. And you could even put I in there as the parameter. And that would, this for loop would create 1 million circles and stick them all into a vector. Right? So, I mean, there are other ways to do this. The point is that you can create 1 million circles, not necessarily this way. And, oh, right, there we go. Right, another way to go about doing it. So both of these programs will create 1 million circle objects. So if we looked at memory, we're creating 1 million circle objects. Each of them have 8 bytes for a radii, its own radius, and each has 8 bytes for its own pi field. So this is what memory looks like. We have our 1 million circle objects, C1, C2 to C1 million. And each of them is taking up 16 bytes, a total of 16 million bytes, or 16 megabytes of memory that's actually taken up at this point. So you notice that pi is repeated 1 million times. Pi is not likely to change. We don't need to have 1 million copies of a mathematical constant sitting around in memory. We want, for reasons that we'll see in a minute, we want every circle to have access to its own pi field, but we really don't need to keep 1 million pi's sitting around in memory. What we'd like is there just to be one pi field, because again, pi is not going to change. Eventually it's going to be final on 3 slides from now. Pi is not likely to change for the running of the program, so we don't really need 1 million separate copies of it, so each circle has its own copy. We'd like there to be one copy of pi and then 1 million separate radii, because right now this is just eating up a lot of memory. You have 1 million identical copies of pi sitting in memory, and there's really no need for that. We need all of our radii, right, because every circle could be a different size, but we don't need 1 million copies of pi. This is one of the things that static is used for. If a variable is static, then there is one and only one copy of that field for all of the objects declared. In particular, all of the objects share a single static field. So as radius is not going to be static, there's going to be a separate radius for every circle object declared. Pi is shortly going to be a static field. And that means that every circle object will share a single pi field. We've created one circle object, and we have one radius and one pi field. We create 4 circle objects. We have 4 radii, again, one for each circle object, and 1 pi field. We create 1 million circle objects, and we still have 1 pi field. And all of those circle objects will now share that 1 pi field. An interesting thing to note is the amount of memory that takes up, blah, blah, blah. If we have a single circle object declared, that circle object now takes up 8 bytes because it just has a radius, and this 1 pi takes up another 8 bytes. So we're using a total of 16 bytes. If we have 4 circle objects, then each circle object now takes up 8 bytes because of the radius field, times 4 is 32, plus the remaining pi field sitting in memory. And if we have 1 million, then each of our 1 million circle objects also takes up 8 bytes because of the radius, so that's 8 million bytes or 8 megabytes plus another 8. So we have 8 million megabytes plus 8 bytes is how much memory is being taken up. Before pi was static, it took up 16 megabytes. We've effectively cut that in half. Not exactly, but close enough. So this is one use of the static keyword. When stuck in front of a variable, we're going to say static double pi equals. It allows that one variable to be shared by all of the objects that are created. Notice we still have one circle class, right? The circle class was the Java code that we actually saw, but now we've created our million circle objects in memory, 1, 2, 3, 4, all the way up to 1 million. Each circle object has just the radius field, and all of the circle objects share the single pi field.
So let me get this straight. But we can still change pi.
So the question was, can we change pi? Pi can still be changed. Pi has not yet been declared final. We're going to do that in a couple slides. I will show an example later on in the slide set, actually towards the end of the circle example, probably gets to it Monday, why we might actually want to change a static field. Okay. How many people feel they understand static fields at this point? Okay, I'm seeing a good number of hands, not everyone. So again, note that pi is not final at this point. Circles, create circles C1, C2, C3, all the way up to C4. I say C1.pi equals 4.3, and then print out C2.pi. Keep in mind that all circle objects share the single static pi field. So what happens there is when I say C1.pi equals 4.3, there's only one pi field. It's going to set that to 4.3. Now when I say C2.pi, it will then read that 4.3 value. Because there is only one pi field, I can set it in one object and read the same value out of another object. It's really, in this example, I'm setting this to 4.3, the single pi field that's declared, whether or not I read it out of C1, C2, C3, or C4. So it's going to print 4.3. Excuse me. So as I said, there's only one copy of a static field, regardless of how many objects are declared in memory. Even if there are 0 objects declared. If I don't create any circle objects, I still have a static field. I still have a static pi field. Seems like a bit odd when you first think about it. But Java, anytime Java sees a static field, it creates it regardless of how many circle objects you're going to go and populate memory with. So, and I'm going to show that example in a minute. Static variables are called class variables. You'll use them interchangeably. It's static or class, and then either variable or field. And the reason it's called that is because for the entire circle, for the circle class, and however many objects you've just created with it, there's only one such pi field, or only one such static pi field. There's only one copy for all of the objects of that class that have been created. So it is referred to either as a static field or a class field, or a static variable or a class variable. Non-static variables are called instance variables, or instance fields. The reason they're called that is for each object that's created, or each instance that's created, it has its own radius. So this is the difference between instance variables and class variables. Class variable means that it's static, and there's one for all the objects, all the circle objects you create. An instance variable means there's one for each object, as opposed to one for all the objects is one for each object. So another interesting feature of Java is, since there is only one pi field, you can actually refer to it by the class name, circle.pi. That's saying from the circle class, not a given circle object, but from the circle class, tell me the value of pi. And the reason is that there's only one pi field. So if you say circle.pi, it knows exactly which pi you mean. If you said circle.radius, what if you have four circle objects declared in memory? Java doesn't know which one you're talking about. Here there's only one pi field, so Java's happy to display 3.14 for you. So if you looked at this program, you'll notice that I've now said circle.pi equals 4.3. in the circle class, there is only one pi class variable, or pi pi static variable. I'm going to set that one variable to 4.3, and then here I'm going to print it out. Thing to keep in mind is that pi field is shared by all of them, by all the objects. I can even call it by circle.pi. So it turns out we've actually used static fields quite a lot. System.in, from the system class, access the in class variable, which happens to be set up for standard input. From the system class, access the out static variable. And that, of course, is the monitor. Math.pi, that's actually where pi lives in the Java SDK. From the math class, access the pi static field. Integer.max value, I don't know if we've actually used that, but from the integer class, there's a field called max value, and that is like 2 billion and change. It's the maximum int that you can have. So we've actually used a lot of these, even though I kind of hid the details from you up until now. Oops, that's from last semester. You can just pretend that I didn't show you that. Okay, what are we doing with staticness? Okay, that's better than I thought it would be. Okay, again, I'm going to be spending time, I'm going to be coming back to staticness and sort of repeating it over and over. So that's good. So this is, we've seen hand puppets and hand shadows that everyone likes to do in the projectors, but I'd do some for you, but I can't reach. These are actual hand paintings that I thought was surprisingly creative. I don't know. I know, isn't that cool? I can show you a whole class of just red slides, but then the rest of the course is going to be on the last day. Well, actually, what I'm going to do is on the last day, I'm going to have a vote for everyone's favorite demotivator, and on the last day, I'll have a countdown. So we'll go through lots of red slides of everyone's favorite demotivator. Okay, back to our circle class. Pi is now both final and static. It wasn't final because I wanted to show how you could change a static field about 3 slides ago. But now it's final, so pi can never change throughout the running of the program. And now it's static. So no matter how many circle objects we declare, there's only one pi field. Right? Pi is now final and static. But this doesn't really do much. We can't do a heck of a lot with our circle class. So I'm going to create a method called compute area. What this compute area does is it's going to return pi r squared. So I was taking my AP test in high school, and I'm going to date myself here, but this was before they allowed calculators on AP tests. This was like the BC level calculus, and I was doing really well. I got my Taylor series expansion perfect. the thing I screwed up on my AP Calculus test was the formula for an area of a circle. That's exactly what I wrote on my AP test. And then proceeded to find the formula for a half circle. I have no idea why, but I remember to this day that I couldn't seem to remember that formula. I get the hard stuff right and the easy stuff wrong. Okay, so here we have a compute area method. What this method will do is compute the area of the circle. And you might ask, well, why bother? Everybody except for, me, knows the formula for an area of a circle. We could easily start creating other shapes in our graphical program. And while you and I know the formula for an area of a circle, what about the formula for an area of a triangle? That's scaling. Or for an octagon, or a dodecahedron, et cetera, et cetera. So you can certainly see why we might want a compute area method when we start having more complicated shapes other than, a simple circle. And all this does is it takes pi, multiplies it by the radius, and multiplies that by the radius, and returns that value. Important thing to note, we have a non-static method. As we will see, you can have static methods in a bit. I'm going to show that. We'll probably get to that Monday. We have a non-static method that can refer to both static fields and non-static fields. And that's an important thing to note, because it knows which radius to refer to. This is being called out of an object, and there is a radius right there. So it knows which radius to talk about. And there's only one pi, so it knows exactly which pi that you're talking about, because there's only one of them anyway. And this will successfully compute the area of a circle and return it to whoever is calling it. So let's say we want to use that method. Here we have, again, a separate class in a separate file. This is circletest.java. We create our circle. We set the radius to 2. We figure out the area, and we call, and then we print it out. So that's going to print out 12 and change, which is the area of a circle with radius 2. So when that method is called, circle C equals new circle. That does the 4 things that we've talked about. Creates a C reference, creates a circle object, makes a C reference point to the circle object, calls the constructor with no parameters. That's going to set the radius equal to 1. I then directly set the radius equal to 2. C.radius equals 2.0, and you're going to see my radius change through the beauties of PowerPoint animation. Double area equals C.compute area. From this, whatever C points to, C is a reference pointing to that circle object, I'm going to call the compute area method. So I'm going to start executing that compute area method. Return pi times radius times radius. So first what it's going to do is it's going to multiply pi times radius. It's going to come up with the value 12.3 and change. The return says that that value is going to get stuck or get placed into the area variable. So we were saying double area, we're creating a new area variable. And whatever value is returned from this compute area method is what's going to get stored in that area variable. And here the value returned is 12 and change, or the area of the circle. So I now have an area variable that's 12 and, well, I guess 12.6. And then I print that out, and it prints out 12.6. So this is our circle class so far. And you'll notice that I've made a slight change from before. The previous, the constructor previously set the radius equal to 1. There I'm not setting it. So if you create a circle and this constructor is called, radius is going to be set to 0 by default. And of course the compute area method that we just went over. So within a method, you need to declare a variable before it's used. Int x, and then you can say x equals 7, and then print out x. So in a method, it goes in order, and you need to print out you need to declare a variable before it's used. In a class, it doesn't matter so much. any instance variable or class variable, meaning a non-static variable or a static variable, they can really be declared in any order. You can have a method at the top of a class that uses a variable that's defined later in the class. As long as you define it there somewhere, Java is kosher with that. So you can actually define things in any order inside a class, but that's not true inside a method. This is very different. For those of you who have seen C++, this is very different than C++. C++ requires them to be declared in order in a class. Java doesn't care quite as much. Okay, this particular, I'm actually going to wait until next time to go over this particular example because it gets into the public and private. So I'll let you out a whopping 5 minutes early. Enjoy the weekend, and I'll see you all on Monday.